Hi and hello everyone. In this video, we'll try to understand decision tree. What is decision tree? Why is that we are supposed to make use of a decision tree and so on. Decision tree basically we say is a supervised learning technique that can be used for solving the problems related to classification and regression. So when I say it is supervised learning technique, meaning of that is we are going to provide here a training data. And in the training data, you are going to provide both the input as well as the output. This particular concept we are going to make use of in order to solve the classification related problems. So it is a tree structured classifier wherein you will find the nodes. We can call them as internal nodes. And internal nodes basically represent the features of the data set. The branches represent the decision rules, and the leaf node, which is at the end, represents the outcome and so on. So it is something like this. A decision tree can be as good as this, wherein you need to have a attribute on the top, what you can call this as a root node, and then based on the answers that you provide, we classify this into two subtrees. So if suppose say you are hungry and the answer is yes, then you will come on to this, otherwise you will go on to this particular subtree. Again over here, again a question will be asked, and based on the answer that we provide, we go either to this or to this and so on. Like so that is how we try to classify the given problem and so on. In decision tree, there are two nodes which are the decision nodes and the leaf node. Decision nodes are basically used to make decisions and have multiple branches. So you can have decision nodes for which you can have multiple branches, and these are the nodes which are used in order to make the decisions. Whereas the leaf nodes, which are at the end, are the output of those decisions and do not contain any further branches. So a node which is not going to have any further branch, you can call it as a leaf node. A decision tree, as we said, simply asks a question, and based on the answer that we provide, it can be yes or no. It further splits the tree into subtrees. The diagram below explains the general structure of a decision tree. So it can be something like this. So you will have a decision node on the top. You can also call it as the root node. And based on the answer that we provide, which can be either yes or no, you will move on to the left side or the right side, wherein you can have again a subtree having a decision node followed by multiple other nodes at the bottom level. And if a node over here is not going to have further branches, then you are going to term this as a leaf node and so on. So then a question comes, why is that we are supposed to make use of decision trees? There are so many algorithms that we have in machine learning. So choosing the best one for a given data set is very important. So whenever you have a data set and wherein you need to go with the problem related to classification, we definitely need to go with decision trees. The reason for going with a decision tree are decision tree basically mimic human thinking ability while making a decision. So the way a human being thinks and makes a decision, the decision tree exactly simulates the same. So it is very easy for us to understand. So in short, we can say wherever I need to make a decision based on the answers that I get, I can easily go with decision trees. So you can say decision trees are used wherever you need to go with classification of data. So let's go with an example wherein there is a data set given containing 14 examples over there, and in this you have four different attributes over there. And then the final attribute called play tennis is the target variable over there. Now these four different attributes have the values like, that is outlook attribute has the values like sunny, it can have a value called overcast, and the possibility is it can also have a value called rain. Similarly, for temperature, the value can be hot, mild, cool, and so on. And in case of humidity, it can be high, normal, and so on. Whereas in case of wind, it can be weak, strong, and so on. And then your training example can be a negative instance or it can be positive instance and so on. So in this data set, we are given with 14 examples. Some of them are positive instances and some of them are negative instances. Now, the important thing that we need to do over here is, if I now have to classify this, if I now have to classify and if I have to decide when the play called tennis will happen, when it will happen and when it will not happen, I need to find the possibilities of that. So for that, I need to classify the data which is given. So in order to classify, the first and the foremost important thing is, I need to first find out the root node. Now there are four attributes given to us. I need to decide now whether outlook should be the root node, or temperature should be the root node, or humidity should be the root node, or the wind. Now, this decision is very important. So, you can decide based on a formula that you need to make use of for calculating the information gain by outlook, or the information that you get from temperature, or the information that you get from humidity, or the information that you get from wind. Whichever attribute is going to give us more information, there we say the information gain for that attribute is high. So if output is going to give me more information, I'll consider it this as the root node, otherwise temperature, humidity, or wind, and so on. Now a question that comes is, how is that I'm going to find the information gain? So in order to go with information gain, I need to find out the entropy for each of these attribute. Now again a question comes, what is an entropy? Entropy basically will talk about the impurity of the data, that is randomness in the values for that particular attribute. So for an attribute called outlook, you have sunny, overcast, rain, and so on. So if there is randomness in the values over here, then it becomes difficult to predict an output of this. So we need to find here basically the entropy for this particular attribute called outlook, entropy for the attribute called temperature, entropy for the that is attribute called humidity, and entropy for wind. So if I get the value for the entropy as high, the meaning of that is it has got more impure data, meaning the information that I'm going to get out of that is going to be very less. So the information gain will fall whenever the entropy value is high. So I need to calculate the entropy for each of this, and then I can find the information gain and so on. So in order to find that, we got some certain formulas which we are supposed to use. I'll show you that. Let's go with this particular example of tennis play, and then we'll try to apply this ID3 algorithm. Okay, so wherein we need to find now the entropy for outlook, similarly for temperature, humidity, wind, and so on. So in this data set that is given to us, there are 14 examples, and out of that 5 are negative instances and 9 are positive instances. So remember, 5 are negative and 9 are positive instances over there. So out of 14, 9 are positive, 5 are negative. So how is that you are going to find the entropy for each? So entropy, as I said, is a metric to measure the impurity in a given attribute. Impurity basically over here is specifies the randomness in data. So if the data is more random, I can give an example over here. Suppose say if you take any particular cricket player, and if the score are the runs made by the cricket player are something like 5, 10, 15, again 10, 12, 14, then you may not be able to find what kind of batsman the person is and so on. But if the score or the runs scored by that particular batsman is something like 50, 70, 100, 50, 90, 70, and so on, there you find some consistency and so on. So you can say the consistent player or the player is inconsistent and so on. Similarly, here when you calculate entropy, it specifies the randomness in data, so which can be calculated as minus PS. SPS over here is probability of S that is positive instances, log 2 probability of positive instances minus probability of negative instances, sorry, not probability, proportion of positive instances log to proportion of positive instances minus proportion of negative instances log to proportion of negative instances, and so on, where S over here is considered to be the total number of samples and all. So in our case S is 14. Now how many are proportion of positive instances over there? Out of 14, 9 are positive and 5 are negative over there. So you need to find the entropy for a given attribute called outlook in this way. So you need to say S equals to 9 plus comma 5 minus. So which means you have 5 negative instances and 9 positive instances in the given data set called S. And then you are going to find out here the entropy for outlook, where outlook can take the values as sunny, overcast, rain, and so on. So now if I find the entropy for outlook, I will write it as entropy of S equals to entropy for outlook equals to minus proportion of positive instances log to proportion of positive instances minus proportion of negative instances log to proportion of negative instances. So when I try to calculate this, I get the value for that as 0.94. So this is for the entire attribute called outlook. Now this attribute can have the values like sunny, overcast, rain, and so on. So then I am going to find the entropy for sunny. So in the given data set, how many times sunny appears? Sunny appears over here, say for 5 times. And out of 5 times, how many times it is positive? 1 time. It is positive for 2 times. And then it is positive for 2 times. So I will say here sunny 2 plus 3 minus. That means sunny has 2 positive instances and 3 negative instances, and so on. Like so, you again replace the formula over here. Entropy for sunny minus 2 by 5 log 2 2 by 5 minus 3 by 5 log 2 3 by 5, and so on. 2 by 5 we are taking because 5 times sunny appears. Out of that, 2 are positive and 3 are negative, and so on. So when you try to calculate this, you will get it as 0.971, and so on. Similar thing you need to do for overcast. So overcast appears over here for 1, 2, 3, 4 times. And how many times it is positive? It is positive here, positive here, positive here, positive here. So all the 4 times it is positive. So you will write 4 plus comma 0 minus. And then you try to find the entropy for that, which will be equal to 0, and so on. Similarly, you need to do it for the rain. So how many times rain appears? 1, 2, 3. And then you have 4, 5 times. Out of 5, how many times it is positive? Not positive. Positive over here for 1 time. Positive, no. Positive for 2 times, 3 times. So 3 positive you have and 2 negative you have for rain. So then you calculate the entropy for rain. When you replace it with the formula that is given, you will get it at 0.971, and so on. So now what we have calculated? We calculated the entropy for outlook. And in that, we calculated the entropy for sunny, overcast, rain, and so on. Now you need to find, once you know the entropy, you are supposed to find the information gain, which can be written as gain S comma outlook. Okay, that is for the entire data set with respect to your outlook attribute is equal to entropy of S minus sigma cardinality of SV by S. V over here can be sunny, overcast, rain multiplied by entropy of SV. Okay, again V over here can be sunny, overcast, rain, and so on. So try to work with this. So gain of S comma outlook, that is gain of S with respect to an attribute called outlook, is equal to entropy of S minus what you are going to write? SV by S. So you try to replace with the sunny now. So how many times sunny appears? You know 5. 5 times out of 14. So minus 5 by 14 entropy of sunny, minus 4 by 14 entropy of overcast, minus 5 by 14 entropy of rain. That means sunny appears for 5 times out of 14, overcast appears for 4 times out of 14, and then rain appears for 5 times out of 14. So then when you try to replace the values, we have the values of all this. So gain of S with respect to outlook equals to entropy of S. So what is the value for entropy of S? 0.94. So you write that minus 5 by 14 entropy of sunny. Entropy of sunny we calculated as 0.971. So you replace that minus 4 by 14 into entropy of overcast, which is 0, and then minus 5 by 14 entropy of rain. Entropy of rain is 0.971. So when you calculate this, you are going to get the gain equals to 0.2464. So this is the information gain for an attribute called outlook. Now, similar to this, you are supposed to calculate the gain for the next attribute called temperature. So the same formula you are going to repeat over here. So how we are going to do this? For temperature. So temperature can take the values as hot, mild and cold. So initially you find for temperature. So 9 plus 5 minus, this is for the temperature in whole. Okay, 9 by 14 and so on. This is going to remain the same. Now for hot, you need to find out over here. Hot comes how many times here? Appears for 3 times and then 4 times. So out of 4 times, how many times it is positive? 1, then 2. So it is 2 positive and 2 negative. So you will say 2 plus 2 minus. And then you can calculate the entropy as 2 by 4. 2 times it is positive out of 4. 2 times it is negative out of 4. So you can replace this and then you get the value for this as 1.0. Similarly, you need to find the entropy for mild. So for that, you find out how many times it appears. 1, 2, 3, 4, 5, 6. 6 times it appears. So how many times it is positive? 1 time, 2 times, 3 times it is positive here, and then 4 times it is positive. So you will write 4 plus 2 minus and so on, and then try to calculate the entropy for mild. You will get the value over there at 0.9183 and so on. Similarly, you need to do for cool. Cool appears for 1, 2, 3, 4 times over here. So out of this, how many are positive? 1 is positive, 2 positive and 3 positive. So you will write 3 positive, 1 negative and so on. So then the entropy for this, when you replace it, you will get it as 0.8113 and so on. Now with the help of these entropies that you have calculated, you find the gain for the information gain for an attribute called temperature. So information gain S comma temperature equals to the same formula you are going to apply, and then try to replace the values. Entropy of S minus entropy of hot, when you multiply by the number of times it is occurring out of total. Hot appears for 4 times, and then mild for 6 times, and this for 4 times. So you will write 4 by 14, 6 by 14, 4 by 14 multiplied by entropy of hot, mild, cool and so on. So when you calculate this, you are going to get the output over here as 0.0289. So this is the information gain from the attribute called temperature. Now similarly, you need to do this for humidity. So wherein you have the values like high, normal and so on. So how you are going to perform this? Humidity. Again, the first line over here, the first statement is going to be the same. Now you find how many times high appears over there. High appears for 4 times, 5 times, 6 times, 7 times. So out of 7, how many times it is positive? It is positive for 1 time. It is positive for 2 times, 3 times. So you are going to write it as 3 plus 4 minus and so on. So then you try to calculate the entropy for this. You will get it as 0.9852. Similarly, you need to do this for normal. So when high is for 7 times, normal is also going to be for 7 times. But how many times it is positive? You calculate 1 time positive, 2 times positive, 3 times, 4 times, 5 times it is positive, 6 times it is positive. So you will write 6 plus 1 minus, and then you find the entropy for that, and you get the value for that at 0.5916 and so on. So when you try to replace these values with the formula that you have for information gain, then you will get the value for gain at 0.1516 and so on over there. Similar thing you need to do for wind. So in wind, you have the values like strong and weak. So how many times strong appears, how many times weak appears, and based on that, how many times it is positive, negative, you find the entropy for that, and then try to replace with the gain, that is formula for the gain, and you get the value for that, and so on. So now you got the information gain for wind, for humidity, for temperature, and for outlook. Now, what you need to do? The information gain from the data set S for with respect to outlook is 0.24, with respect to temperature 0.02, with respect to humidity 0.15, and with respect to wind it is 0.04. So out of these four, which particular attribute is giving us more information? That is very important. And if you see here, outlook attribute is giving us more information gain. That means it has got less impurities. So in that case, we need to consider this particular attribute as the root node. So selection of root node is very important, and for that you are supposed to calculate entropy and the information gain. So what you are going to do now? You are going to form a tree. So you write the root node as outlook, and now outlook is going to have three branches. As you know, it will have a value called sunny, overcast, and rain. So now when the outlook is sunny, can you decide whether you can play the game or not? No, because sunny appears for 5 times in the given data set, and out of that 2 times it is positive, 3 times it is negative. So I cannot make a decision over here. If the outlook is sunny, I cannot make a decision as yes or no for the tennis play. But coming to overcast, if you remember, overcast appears for 4 times, and all the 4 times it has positive instances, which means 4 plus 0 minus you have for overcast, which means if the outlook is going to be overcast, then you can directly say here that you can have your tennis play. Yes, for that. Here you cannot decide because some of them are negative, some are positive. Similar is the case with rain. When you go with rain, you cannot decide with this because rain appears for 5 times, in that it is 3 times positive, 2 times negative over there, and so on. So you cannot make a decision over here. Now what we need to do is, further we need to find out here the entropy for sunny and for rain and so on. That is entropy with respect to sunny and entropy with respect to rain. As you are not able to make a decision over here because of the nature of this particular, or because of the number of times it appears with positive and negative instances over here. So what we need to do now? So sunny, comes with, it appears to us in D1, D2, and D8, D9, and D11. So 5 times it appears. So what you are written? D1, D2, D8, D9, D11. Sunny appears in these particular examples. So now what you need to do is, you need to now find, by taking the example called D1, D2, D8, D9, D11, you need to now find the entropy and information gain for temperature, for humidity, for wind, and so on. Okay, as we have done for 14 training examples or examples, you can also now find for these 5 and so on. So attribute temperature, which can take a value as hot, mild, cool, and so on. So you need to first find the entropy for sunny. You know the entropy for sunny, already it is calculated, it is 0.97. Now in this case, this is all the examples with respect to sunny, where sunny appears. So earlier case we have taken 14 examples, now you are taking only 5 because in these 5 examples sunny appears. So you will calculate S of sunny, that is entropy of sunny, which you have already done it, which is 0.97. Now you need to calculate the entropy for hot, entropy for mild and cool with the same procedure. So hot appears how many times? One, two times, and then both the times it is negative. So 0 positive, 2 negative. Mild for one time it is negative. So sorry, mild appears two times, it is negative and positive, so 1 plus 1 minus. Cool appears for one time, which is positive, so 1 plus 0 minus. Replace this with the entropy formula, you are going to get some values for that. And then when you replace this with the gain formula, you will get the gain for temperature. So that is 0.570. Exactly the same procedure you are supposed to follow over here. Now, similar thing you need to do for humidity. Okay, with respect to sunny. So for sunny appears for 5 times. So with respect to this example only, you are supposed to calculate for humidity. Okay, so you calculate for humidity over here. Then you will get how many times high appears over there, normal appears over there, and then you calculate the gain for humidity. Similarly, you need to do this for wind with the same examples over there, that is 5 examples over there. Then you find the entropy and gain for wind. So you get it something like this 0.192 and so on. So the gain for temperature with respect to sunny is zero point 0.5, humidity it is 0.97, and it is 0.192. So the one which is having the highest gain over here. So the highest gain you find is coming with humidity 0.97 when compared to temperature and wind. That means this is going to be the node at the subtree level. So you can write in sunny now. When you have written sunny here, you could not make the decision because some of them were positive and some were negative. So now you can say under some sunny, you can write humidity because humidity has got more information gain or it is providing more information. So you will write under sunny humidity. Now, if the humidity is high, you can say no. If it is normal, you can say S and so on. Similar to that, you need to find here under rain. You cannot decide here again. If the outlook is raining, you cannot decide because here you have three positive and two negative instances. So what you need to do now, you need to find where rain comes. It comes in D4, D5, D6, D10, D14. You can just cross check this once. Rain appears to us here D4, D5, D6, and then D10 and D14. So D4, D5, D6, D10, D14, and so on. So take those values with respect to rain and then calculate the entropy and the gain for temperature, humidity, wind, and so on. When you do this for repeated number of times, you will find here that with respect to rain, temperature attribute is giving you the gain at 0.01, humidity is giving 0.192, both are same here, whereas wind is giving 0.97. That means the highest gain over here comes with wind, which means in rain you are going to have an node wherein you call it as the wind, and then you have the values for wind as strong and weak. Based on that, you can decide whether the play can happen or play cannot happen over there and so on. Like, so this is how you are going to classify the data which is given, and then you can find out when the play will happen, when the play will not happen, and so on. So by this you can say if the outlook is going to be overcast, you are going to say the play will happen, and if the output is going to be rainy, and in that if the wind is strong, then you will say it will not happen, and so on. Like, so this is how you need to work with this particular algorithm, ID3 algorithm, wherein you can go for classification problems and so on. So if you like the video, please share the video and then subscribe to my particular channel. Thank you.